Right. Are we on?
Yes.
Okay. Welcome. Welcome to our session, Bleeding Edge Software today. Um, so, hope you all enjoyed the keynote this morning. Wouter and Vincent that did a live deployment of an app in 10 minutes. Really amazing. So, let's first do a show of hands how bleeding edge our audience is. So, how many of you use Spring Boot? How many of you are on 2.0? Or higher, 2.2 even? Nice. How many of you are on Java 11? 12? 13? Nice.
Oh, one. Wow.
All right, so in this session, we'll talk about a couple of things. So let's go back in time. 3 years ago, we decided to break up a monolith application into microservices. And in this session, we'll actually focus on one of the big things that this monolith application would do, and that would be authorization and routing. So that's basically where this Edge service microservice was born, and so we started to look for some software to build this Edge service. And when we built it, we ran it for about six months in production, and after about 6 months, we started to do some performance testing, and we concluded that the Edge service would not really perform as we liked it to do. So let's take you on a journey and see how we did the migration of that application. And see how that went. So I'm Erwin, and this is my colleague Martin.
Hi, Martin. Joined the team about 2 years ago.
Yeah, we've been working several years on breaking this monolith application down into microservices. It's been a fun time, right?
It was. Is. Sorry.
Right. So, without further ado, so we were coming up. We were thinking of a service that would basically add some governance, because if you have this, you don't have any structure, right? Any request from the outside would land up in whatever microservice, internal microservice in the bank. So that's not what we wanted. And remember, this was in July 2017 where we did this. So we looked for software to build our Edge service, and basically we found our candidate, which was back then Netflix's own Zuul, and we implemented as a facade. That means that you will only, the benefit of that is that you will only expose one domain to the outside world and hide all the internal microservices. And this also allowed us to do authorization. And there's a possibility, that's what everybody does at the moment. These microservices are able to define their own endpoints in the configuration which this Edge service is reading. So the reason why we chose Zuul was because back then it was the most mature framework to go with, routing framework. And also, since it's part of Netflix's OSS, it has good integration with other software like Ribbon, Eureka, and Hystrix. So, like I was mentioning before, we ran this in production for 6 months, and we saw gradual growth, and at some point we saw that line that we could just keep on going, the trend, and we did load and stress tests with the future numbers, and that's where we concluded that basically Zuul would not held up to the load that we had hoped for to do.
So when we did some predictions on our current Zuul implementation, we were of course talking about platform growth. We were talking about scalability for, let's say, memory usage, CPU usage, and throughput. So we knew that the current platform that we had running handled roughly 100,000 requests a minute. So we knew that at some point our same service, our Edge service, should at least to do the same amount of traffic. So we made some predictions for 2018 when we really started this and put this live. So we started small. We thought, okay, we probably will handle about 500 TPS on average in 2018. And in 2019, that might scale up to 2,500 TPS. Which sort of means that, or we also, sorry, that's what we did that. So 2,500 TPS. And that was roughly about 1,000 service endpoints that we thought would be enabled in the platform. A service endpoint is basically one URL in a service. So when we go and look at the real platform growth, so on this graph, you see 3 lines. So the applications that are running in our test environment, the applications that are running in our production environment, and the active spaces that are in use now. Every team has its own space. They deploy their applications in. They first start on the test environment, obviously, and then later on they push the same, well, perhaps the same code, maybe not the same code, to production. You're probably wondering why is this huge dip in the blue line, the applications in the test environment. At some point, well, the platform started growing. You say this nice linear growth, as Vincent also mentioned during the keynote. We got more and more and more applications, and at some point, the subscription they have on our cloud platform, Azure, didn't really hold up. So we had to change subscriptions, which actually meant that every team should redeploy the applications on a new environment, a new foundation. And some of the teams did. That's why we never dropped all the way back to 0. But a lot of teams didn't do that directly. So it took some time, but now we're at least back up to the same amount of applications we had back then. You might also be wondering why there's a gap in the application number in production. And that's just because we didn't care about measuring back then. Right? Why should you? So we have now about 350 apps running in production. They actually consist of around 1,200 endpoints. So that's slightly more than we expected. The throughput is actually a bit lower than, well, it's actually lower than we predicted. I don't know if you remember, if you read the abstract, we talk about 40,000 requests a minute. We already went over that. We actually hit 74,000, correct me if I'm wrong. 74,000 requests a minute, so that's more than 1,000 TPS, but that's by far not 2,500 TPS. So the other thing I mentioned was memory usage, CPU usage. At some point we did the predictions and we wanted to try out what our current Zuul implementation could do with 500 services configured. This is a screenshot from Mission Control, Java Mission Control. When we started, you see these lines for CPU and memory. This is just basically running the application. We weren't even running a stress test or something. This is not even on the high load. It's just starting up the application, putting some load on it, and it immediately went out of memory, or maybe not went out of memory, but it scaled up to the max committed memory, and CPU went to 100%. So clearly, this did not hold up for us. Other things that we knew about back then is that we use Spring Boot 1.5, and that uses Tomcat, Hystrix, all this stuff. And they all use the Servlet API, which is a blocking API. You have a lot of threads. Every thread uses CPU. Every thread consumes memory. So yeah, we could scale up more and more and more, but yeah, at some point it was just unmaintainable. So we need to go look for something else. Other things that made us make this choice, there were some other limitations. For example, Netflix announced that they will put Zuul and Hystrix and some of the other ribbon, for example, in the maintenance mode, which means they are not going to do any support on it anymore. They might do some bug fixes, really some highly secure or highly vulnerable stuff. They might do some bug fixes on that, maybe some small pull requests, but nothing else anymore. And we also got the announcement from Spring that we're no longer going to support Spring Boot 1.5. They actually had the last release last August, so not even that long ago. But now, of course, 2.2 came out recently. So there was another reason why we had to do this. So we were on the look for alternatives. During our whole migration phase from our monolithic application to microservices, we had some hands-on help from Pivotal. It was running on Pivotal Cloud Foundry, so it makes sense that they helped us. And well, through those consultants, we got the nice ability to get a hands-on session with Spencer Gibb. Spencer Gibb is one of the authors of Spring Cloud Gateway, and he was really eager to show us what that could do. It seemed a really good fit for our use case. It's also, it's a gateway, just what the name says. And it supposedly would be a lot easier to configure. You could do routing based on just requests, URLs or headers or time of day, whatever. You could do it on everything, and it was a lot easier than do that with Zuul. And of course, we also heard about Zuul 2, but Spring's statement was we're not going to support Zuul 2. The main reason for that was that it was a major rewrite, so everything had to be rewritten. It was not backwards compatible. And the other thing was it wasn't open source yet, so we couldn't really use it this Spring. So in the meantime, Spring Pivotal was already said, okay, we want something new. So we went for a Spring Cloud Gateway. But then, of course, yeah, in that phase, we were going to face some challenges. How can we, for example, do a seamless transition to the new version of the application when we completely rewrite the whole application, but it's a running application? So how can we make sure that we do not cause any downtime? Spring Boot 2.0 came out. We also wanted to migrate to that, so there was more like a technical challenge. We had to rewrite some stuff there because it was not entirely backwards compatible. Our biggest challenge probably was our movement from servlet API to the non-blocking API. The Spring Cloud Gateway is completely built on the Spring Reactor platform. So that's a completely different way of thinking. And last year, September, Java 11 came out. So why not, right? Let's try to use it at least if it comes out and see if we can do that. But in the meantime, of course, we also still had to do the maintenance on our running application because, yeah, there were still new features that we had to implement. So how can we make sure that we do that? So how can we migrate it?
Right, indeed. So we're in July 2018 here now, and what we wanted to do is, of course, do the migration as smooth as possible without actually causing customer impact. So this is what we did. We copied the main edge router, and we basically So what we did is we started from scratch, but it would again be an edge router, actually only serving the bank employees this time. Meaning, if we would run into any trouble, we would have no real customer impact, and that's how we actually wanted to build our confidence. So what we did is we built an edge service again with the routing and everything. This time with the Spring Cloud Gateway, using Spring Boot 2 and Spring Cloud Finchley. Still on Java 8 though. So back then, of course, being an edge service for only bank employees and with only one application behind it, we had near to nothing, near to no traffic, and we were practically able to tail the logs. I mean, of course, that's not what we do today, but it's how we had the full control, right? So we were tailing the logs and see if there would be any errors, and if there would be any error, we would have no real customer impact. So that's basically how we built the confidence. So we had that running in production at some time. And from there, when we had the confidence, we started to do the edge service that would still run in Zuul. But back then, October 2018, and we would copy the develop branch and remove all the routing part. We would only keep the test cases, right? So this was, of course, to avoid any regression. So what we did is we had a second branch. We kept the tests. We kept all the automation, the monitoring, of course. So as less rework as possible, and we would rewrite the filters one by one. Before rewriting a specific filter, we would enable the specific test case for it. So we would always apply TDD, and so we built this thing in 3 weeks, right? So, but the Edge service went live after half a year. You might wonder why. This was because we started with the performance tests after 3 weeks, and it took us 6 months to get it up to speed and perform as good as Zuul. So from there, let me highlight first how we do our performance tests. We use JMeter to create the scripts and also run the scripts. And then we had 2 other tools where we would actually create reports or see why certain things happen. So we used Visual VM to feed on the application's JMX data. And we would use Dynatrace to be able to look into the pure paths to see on method level what would perform bad or worse than our Zuul implementation of the Edge service. So with these 3 tools as our basic setup, and this as the basic setup for the load that we used for both Zuul and Spring Cloud Gateway. So this was always a 40-minute run where we would do a ramp up of 5 minutes to get to 150 TPS and hold that load for half an hour and then ramp it down for 5 minutes. The backends were actually having no delays, the backends that we used to test against. And the reason why we had that is, of course, we're not looking to test the stubs, right? We were here to test the application itself, the Edge service. So with this in mind, we had our baseline to test against our benchmark, basically. And you can clearly see that even during the ramp up or ramp down, you'd have no significant fluctuation. And it was about 20 milliseconds on average in terms of response time. So this is the response time that you're looking at. So next test was actually the first run that we had for Spring Cloud Gateway. And you can still see how Zuul would compare up to that, just for clarifications. You can see that during the ramp up, we were kind of happy that it performed around the performance of Zuul. But as soon as we were having the full load of 150 TPS, you can see that it increased like about 3 times as much. And also it would fluctuate a lot, which is not something that that we were looking for. The schedulers that you see up there, they're actually Netty's non-blocking I/O threads, because for a Spring Cloud Gateway, Netty takes care of all the dispatching. So we were not happy with this result, so we went back and changed the configuration. So we changed it to be the double amount of schedulers, right? And you can immediately see that it became quieter, less fluctuation, yet not really what we were looking for, because even after coming back to the drawing board and again changing the amount of schedulers, which is naturally again going to be doubled here, we were still not very happy, because at this point you'd still have about 1.5 to 2 times the slower performance against compared to Zuul. So we were not happy. So we went back to the drawing board and we were wondering like what should we be doing now.
So yeah, indeed. What now? So as I said earlier, we had help from Pivotal. So we thought after a couple of months of testing this, we said, yeah, okay, we cannot really figure this out where things go wrong. We did all the tests ourselves. We checked the Dynatrace, we checked Visual VM, and of course we found some stuff in our own code that was actually blocking instead of non-blocking. One of the things as I said, well, it was hard for us to go from server API to reactor stack. It's a different way of thinking. So yeah, of course we made some mistakes there. So yeah, we didn't know what to do next. So we tried to strip down our application to a bare minimum that had the routing, had the authorization part in there, and some other filters. And we actually shipped this application to Pivotal itself. We tried to ask if Spencer Gibb could have a look at our application, and luckily he was very willing to do that. The first reaction we got was, okay, wow, that's quite the application you built there. We still, until this day, don't really know if he said, okay, that was, wow, good job. I didn't know that you could do this stuff with my code, or it was just unexpected what we built with it. I don't know. But anyway, he said that. So the other thing he said, okay, we are already working on a new version. Spring Boot 2.1 was already out. It would come out very soon when we did this. And after that release, a new version of Spring Cloud Services would come out, Greenwich. So he asked us to test that. Back then, it was still a milestone. You might probably know that Spring uses milestones first. After that, they could release release candidates, 1, 2, 3 release candidates, and after that, a general availability release comes, and after that, they do some bug fixes, and then you get the service releases. So yeah, we did all these tests, and also we implemented the new version, but because it was a milestone, we didn't want to use that in production. But after a couple of milestones, the release candidates came out, and yeah, improvements were definitely there. It definitely was faster, but we suddenly had failing tests. And we didn't change anything in our code. It was just a dependency upgrade, in our mind at least. So yeah, we thought, okay, what happened here? We had a lot of test coverage, as Erwin explained before, but with TDD, we at least tried to prove that our code is working correctly. We also had the cucumber test, or feature test, and yeah, suddenly some of those failed. So yeah, what's the next then, right? Luckily, it's an open source community, so we went to do some issue reporting on the GitHub. This is just a number of issues that we either reported or had some input in. So yeah. This last one, by the way, the Hystix one, is actually closed because Hystix is in maintenance mode, so this is just not going to fix this. The Spring way of saying, okay, it's closed. So yeah, we worked on these, and release candidate 1 came out. Some other tests were working, but some other tests broke. And then release candidate 2 came out. At some point, the general available release came out. It was actually January this year. And we thought, okay, cool. Now the Vue official version comes out, so let's implement that. But that actually broke another test on us. So we went back to GitHub, did some more issue reporting, but at some point, finally, talk about March now, so it's 2 months later, March 7 to be really precise, my favorite bit. All the bugs were gone. Well, probably not, but at least all our tests were working successfully now. So we ran all our unit tests, all our feature tests. We also ran another load of stress test. If you remember, this is Zuul, about 20 milliseconds. And well, these were actually the results of Spring Cloud Gateway. So they're, well, just slightly slower than Zuul, but at least we thought, okay, this is acceptable. We can live with this. We already saw some minor improvements that we could do, so we put them on the backlog and could work on them later. But at this point, we say, okay, let's do this. Earlier in the slides, I said that we're using, with only 500 services configured, 100% CPU, and it went all the way up to 5 gigabytes of committed memory. And this actually is running production now with a lot more traffic, with only about 20% CPU.
And good to mention, we're using 4 schedulers again, right?
indeed, we're back to 4 schedules like we started this with. And it's actually using less than 500 megabytes of memory, which is actually pretty impressive with the load we have now, compared to Zuul at least. So of course the next step would be, because we were happy now, yeah, we want to go to production. This was one day after the service release came out and we ran out all our tests. So we're not talking about a Friday. So we wanted to go live on a Friday. And why not, right? We trust our system. We have all the monitoring in place. If something goes wrong, there are a lot of people shouting in chat rooms if it might go wrong. So we thought, okay, let's do this. We have our blue-green deployment, which I will show you in a second how that works, if you're not familiar with the term. So we used our blue-green deployment to deploy, because we knew that if we do that, we should not cause any downtime. So the blue-green deployment, what you actually do, takes time. So you have your application running on 4 instances, for example. So your traffic goes to all these 4 instances. Of course, we started with Zuul. This is our blue app. This is the production app. And then we start the process. Of course, this is automated. We have some steps in our pipeline. We use Jenkins, by the way. We have some steps, some manual approval steps in the pipeline so that it doesn't go automatically all the way to production. We can intervene and stop it if we really want to. So we have the 4 applications or 4 instances running. We create 1 new instance for a green app, Sprinkler Gateway, and we want to see if this actually starts up. Because if it doesn't start up, we have to start again. We might have had an error somewhere. And actually, what happened was indeed, first time we tried this, the application didn't even want to start. In the end, it was a really small thing. We had our configuration server separately from our application. We made an error there. I don't even know what happened exactly. We forgot to merge a PR or something like that. So it was a minor fix. We did that. So we started over. Back to our green instance, which actually was green now because it started up. So what you do then is actually you map 1 route to your new instance. And then, because the system we have set up at the bank uses a round robin principle. So that means that 80% of the traffic still goes to the old instances and 20% goes now to the new instance. So at this point, we're actually using 2 different frameworks. We have Spring Boot 1.5 on the one hand with Zuul, and we have Spring Boot 2.1, by the way, now, with Sprinkler Gateway. Of course, we did very careful monitoring. We're looking at all our dashboards, looking at the chat rooms. We let this run for a couple of hours, and yeah, it worked fine. We didn't see any regression. We didn't get any errors. So we went on. So we ramped up another 3 instances so we can spread the load nice and evenly. Of course, we hoped that we would use fewer instances because we knew that it should use less memory and less CPU. But just for to be on the safe side, we scaled it up to the same amount of instances. Of course, these also started up because the other instance started up. Then you map all the routes to it, so all the traffic goes there as well. So now you're actually running with 50-50. Still Zuul on the one hand, Sprinkler Gateway on the other end. Yeah, everything worked fine, so there was no reason for us to roll this back. So we went forward. We removed the traffic from the old routes, so no more Zuul. And we removed those applications. And so this was March. We have been running Sprinkler Gateway ever since, so we're still happy. But coming back to the subject of the presentation, we talk about bleeding edge software. Of course, it's very cool to use bleeding edge software. But as you probably might well know, yeah, with new software, it is pretty common that there is still a lack of documentation. Because who wants to write documentation, right? Or read it, by the way. So yeah, if you want to search something, and you're the first one using it, or at least one of the first ones using it, yeah, you could go to Google, you could go to Stack Overflow, but nobody else probably asked the question. So of course you could go to GitHub, and that's what we did. And then yeah, you can do that. You create your bug, or you do a question there, and yeah, you get a reply. You get a very fast feedback. You might even get a bug fix within an hour if it was really indeed an issue. But still, you have to wait on the release. So, for example, as I said, the general release was in January. Yeah, the first service release was in March. But if you're blocked by that, yeah, you have to wait 2 more months before you can actually go live. The other thing, was very cool for us, but also a pain perhaps. If it was, as I said before, right, the blocking versus non-blocking API, especially if you don't really know what's happening, you want to debug your code. It's really difficult because all the code is lazily evaluated. So yeah, you can add a breakpoint, but it might be triggered, but it might not be the moment when it is actually handled. As Evan said before, yeah, we enabled all the tests, but yeah, you should have the test. Otherwise, you cannot see that your code might break, even with just a dependency update. So yeah, just updating a dependency and say, okay, now everything must be fine, but then you should have your test coverage. If you don't, yeah, you might have customer impact. You don't want that, obviously. The other thing, as I said, we wanted to use Java 11. It came out by the time we went live. It was Java 11 came out in September, and we went actually live in March. So just before Java 12 actually came out. Pivotal said actually we're only going to support LTS versions. They actually also support Java 13 now even. So they actually don't only support LTS versions, which is very cool. But there was a big change from Java 8 to Java 9, where they completely restructured the whole directories. So they thought actually, okay, it's a minor change perhaps from Java 8 to Java 11. We just updated JDK and that's it. But they broke something in there. So there was also a bug in the build pack, which meant that certificates, for example, didn't work at all. And of course, you want to secure your services with the, HTTPS, for example. So yeah, we went live with Java 8, but at some time, new build packs came out that fixed that issue, so we could actually go on with Java 11. So yeah, the open source community very helpful, and it's also you can also contribute yourself, obviously, but it's all open source. The whole Spring platform. But also, yeah, keep in mind you have a fast feedback cycle, but it will still take a long time. Right? So back to you, Evan.
Right, thanks. So, like Martin mentioned before, we hit 74,000 requests like a week ago, and I think we've been updating this number quite a lot of times now, right? Since we started planning this presentation. So we're actually in a fast-pacing world where your dependencies are constantly changing. I mean, I'm not saying it's fast like in front end, but I think it's really getting there. So on October 17, actually, the team did implement Spring Boot 2.2, which is very cool.
The day it came out, yeah.
The day it came out, indeed, awesome. But the thing is that we are depending on a Spring Cloud dependency, which is actually Spring Cloud Hoxton, which is not yet marked as a general release. So we're not putting that in production. It lives in a branch, if I'm not mistaken, indeed. So we're actually constantly monitoring for new dependencies so that we are able to be able to serve our customers something better, right? Without actually having a regression. I mean, it has to be an improvement compared to what you have, obviously. So looking at the next table, these are all the dependencies that we either have or will still be migrating to. So we have already migrated to Spring Boot 2.2. And if you look at Hystrix, we have actually rewritten one of our applications, which is not the Edge service, by the way, to use resilience for J, and we're still kind of experimenting with that, and we're trying to get a stable environment with the dependency before we would actually rewrite the Edge service to use resilience for J. We've never used the Hystrix dashboard. We would actually feed our dashboards because we have our own dashboard. We would actually feed our Hystrix data on the application's metrics, which is coming from Micrometer. Ribbon is still being used, actually, because again, this is part of. The replacement is, which is Spring Cloud Load Balancer, is still part of Spring Cloud Hoxton. So the same story applies here. And everybody has witnessed the Zuul 1 to Spring Cloud Gateway migration, which we have done some time ago. And the last one, Arceus, we've never actually directly used that, but we do have our configuration externalized in a Git repository, which is served by a config server to our applications. And not to forget, we have, I believe we have one service that runs in Java 13 now, right?
In a test environment.
In a test environment, because the platform, which I forgot to mention earlier, where we run our microservices on is PCF, and the platform will have two environments in our case, so the production and the test environment. So there's no build pack yet for production to use Java 13, and that's why it's not yet in production. Maybe that changed today, I don't know.
Yeah, maybe.
That's how bleeding edge we are. Another cool thing, I think I heard that yesterday or day before yesterday, somebody mentioned, is we would like to automate the way we update our dependencies, right? Without having to scan it manually and then see if there are new dependencies and then manually test. And of course, we have a continuous integration pipeline, which triggers after we update the dependency. But so somebody mentioned something like the following. So what if there would be a plugin or a tool that would scan your project automatically and then look for updates, and then run your test set against that dependency, and then when successful, create a pull request, and then the only thing that we have to do is merge it. And that's actually what we're also looking into. The thing is actually, you're saying GitHub, right? I'm not sure about the regulations if we are allowed to let GitHub scan. I mean, in the first place, it's not in GitHub. We have a...
No, I know what you mean. You talk about Snyk, right?
Snyk, yeah. So Snyk, I have ran a pilot with Snyk, and I mean, if you're working in a large organization, and Snyk was new, nobody else had used it. There is actually a process where you have to go through to be able to use Snyk, because Snyk again will read through your POM file in our case, and because of that we had to go through the security office and get some forms filled in. I don't know, it's a lengthy process, and you don't do that the other day.
But indeed, it is similar to what Erwin described. So indeed, you could use it to scan your dependencies, and it might indeed create, or it can indeed create a new pull request for you yourself. But then there are multiple plugins. We actually use Bitbucket in the Rabobank. It could be installed there as well, if I'm correct. And we could potentially do it there. But yeah, we have regulations. At some point, we might be able to use it, but we can't use that right now.
Yeah, but the thing is, we are constantly in the lookout for these kind of nice things to have.
Yeah.
Because you want to focus on your creativity and not so much on the administration part of your project. Right. So, which leads me to the final question. So if you have any other questions, please shoot, or you may go and have beer.
It's definitely time for that, right? Yeah.
So questions.
5:30.
Or you may also come here if you.
Yeah. Yeah. Okay. So the question is, if you have a bug in your non-blocking code, or perhaps potentially blocking code, actually, yeah, how can you trace that? What kind of tools can you use to fix that, or at least try to pinpoint the bug? So one of the things that we used was actually Visual VM, because when you the one in the tabs of Visual VM can actually show all the threads, and if you run your code with a stress test, for example, you expect certain colors in there that say if it is waiting, parked, monitor, well, all the states that threads can have, and yeah, you know which color or which state it should be in. But if you then suddenly see that it is, I think monitor, not entirely sure, don't shoot me if I'm wrong. If you suddenly see that one of your threads goes into that state, you know something is wrong. With that, you can also find out actually what the methods were doing, because you can do a thread dump, and then you can pinpoint it. Not easily, but you can sort of at least try to find out where it happened. Well, actually, not so much, luckily. We had some stuff because we do call other services, for example. And yeah, we used to try a web client for that, which is the non-blocking version, obviously. But there are also just parts where you think, okay, you are non-blocking, but when you look in the code, it's actually, okay, yeah, we are blocking. If you just do some I/O, for example, try to read a file, yeah, that's blocking. So you should use another API for that. It's hard to trace down, hard to track, but yeah, in the end, we found it, and we don't see any blocking code anymore. There are tools for this to check for blocking code. I know they exist. I just don't know the name. There's an API for that, I guess. Other questions? No?
Okay. Thanks a lot.